Hello everybody, we present the paper Error Evaluation of Semantic VSLAM Algorithms for Smart Farming. This work is a collaborative project of Friedrich-Alexander-Universität Erlangen-Nürnberg and Technische Universität Ilmenau. In our project, we are developing a mobile system for automatic monitoring of crop fields, such as the one in this video. One of the used sensors is a camera, from which we can retrieve a digital twin. This is commonly known as Visual Simultaneous Localization and Mapping, or VSLAM. However, VSLAMs assume static scenes, but our world is dynamic. Furthermore, the generated point clouds usually do not contain information about the object class, but only color. A solution to both of these challenges is the use of a semantic visual SLAM. Therefore, we propose to extend one of such VSLAM systems, namely OpSLAM2, with a semantic input. In the remaining few minutes, we introduce the system architecture and briefly explain some of our experiments which can be applied to any visual SLAM system. We conclude with future work and where you can download our implementation. In the most simplified way possible, we can think of OpSLAM2 consisting of a tracking and a mapping module. And the inputs may be RGB and depth images. Now we propose a third input, which contains per pixel classifications of objects, for example green for static objects and red for dynamic objects. This input is then used to mask out dynamic regions for camera tracking, and to create semantic point clouds and octomaps besides the usual RGB point cloud. Our work was inspired by the great work of the authors of DS-SLAM and Semantic SLAM. In contrast to them, we are proposing a dedicated semantic input, instead of tightly integrating a neural network into the whole architecture. This allows for an easier integration of new object classes like watermelons, as in our case. Therefore, we call our system SI-VSLAM. Our research is currently focused on reconstructing watermelon fields. In order to systematically test our system in a controlled environment, we are using Blender to generate the required inputs for SI-VSLAM. On the left, you can see the virtual scene, and on the right, the generated data. This data is then used in the experiments. In some parts of our experiments, we test the system's performance on tracking the scene. For example, by investigating how the image brightness affects the absolute trajectory error, or ATE. We found that increasing the brightness of the RGB images will decrease the number of tracked feature points and lead to a higher trajectory error. In other experiments, we discussed the effects on mapping when the semantic images are, for example, distorted. According to Zhuang and co-workers, semantic images might be dilated and eroded. We found that depending on the camera movement, this may result in stretched or missing parts in the point clouds. And as a last example, we combined static and dynamic scene parameters to investigate how the number of plants influences the robustness of the system. So for example, you can see that in this scene there are 3 plants, and in this scene there are 16 plants. And the experiments we conducted ranged from 0 plants to 111 plants. And we found that in a static scene, which you can see here, more feature points are not always better regarding the ATE. So the more plants we have, if they are identical, they can increase the ATE, as you can see here. They may, however, help to increase the robustness of OrbSLAM 2 even in dynamic scenes, which you can see here. So here's OrbSLAM 2, and the robustness is increased the more plans we have in the scene. However, our approach using semantic input has superior performance in dynamic scenes. You can see it here as SI-VSLAM, because we can filter out dynamic objects. More details can be found in the paper. In future work, we are finally going to test SI-VSLAM on a real watermelon field from a local farmer. We are currently training a neural network for watermelon segmentation to make this possible. We are also working on the integration of radar to provide even more insight into crop growth characteristics. If you are interested in testing SI-VSLAM, please feel free to use this link or check out our paper. Thank you for your time, and I'm available to take your questions.